Okay, so hi everyone, Senan on this side, and in this video we are going to solve this problem statement. As you can see, maximum sub array sum, and it's a pretty classic problem, and it is so classic that it has a special name for the algorithm, which I'll disclose when we go and reach the end. But let's spend some time before I've solved this algorithm. So let's do that and think about the thought process how I would approach this problem. So the thing is, the whole problem is being solved on a Word document. So it's not on a compiler, not an IDE. There's no IDE. I just copy pasted this from lead code and I'm trying to just solve this, right? This allows me to be well aware of the syntax, the syntactical error, non-grammatical error in the code, and I have to keep track and I have to minimize the error before I just copy paste this code and run this on a compiler. So this is a bit different format that I'm trying to do because this would actually help me and learn some stuff. So first of all, which is this font? So if you're worried about the font, I know I'm not using an IDE, but I definitely am using a monospace font, which is JetBrains Mono, and in that it's bold. So JetBrains Mono has many variants, so I'm using the bold variant, not the italics. So let's see the problem statement, and I'll just write everything right. So I would have some assumptions that I'll write this with, and the code could possibly have some errors, but I'll try to do as minimum of them as possible. Anyways, I'll copy paste this code and run that on lead code to check if it is actually working or not. So you'll be given an integer array nums, find the sub array with the largest sum and return its sum. Okay, so the first assumption that I got into my mind is what what to do when there the size when nums dot size is equal to 0. What do I do in that case? So the assumption one is nums nums dot nums dot size is greater than 0. That's the first assumption. Second assumption is what can we return, because no sub array could also be a sub array, right? So there we are not selecting any element. So is that a sub array? So this question is this treating that no element as a sub array in itself or not. So for that I'll say uh, at least at least one number should be selected, right? What this will do is basically, let's say if your nums array has all the unique elements, need not be, let's say it has unique elements and all of them are negative. So in that case, if I choose no array, so the sum would be what? It would be 0, but I won't return 0. I'll return the minimum value of all the negative values in this nums, right? So the answer of this could be negative as well. So I am not assuming that the size is uh, 0. See, JetBrains Mono. Okay, okay. So first of all, the font is a bit, selecting the correct font. Okay, so at least one number should be selected, so my answer could be negative in that case. uh, a test case, possible test case, if all the values of nums is greater than or equal to 0, So in that case, the answer would be the sum of all the elements, right? This problem is only causing you some problems when you have negative number in the nums array. Find what could be a particular another assumption. So will the answer fit into a 32-bit integer or not? The point is, given this function signature, this int and this, you know that the value is an integer, and I am assuming that the value can be stored in this int. Otherwise, what you could do is just return long long, right? You could do this, but I won't be doing that. So assuming int, and assuming if the sum could go beyond int max, what could be the maximum value? In that case, I could maybe just return int max, right? But for this test case, for this problem statement given as in lead code, we know that the values would fit into a 32-bit integer. Yep. So whenever you are writing a code, you need to think about these cases, right? What if the nums is 0? So I'm saying no. Nums, if you will always call this nums array when it has at least a single element. So the caller of this function should need to keep track of this idea that it fails in the case of negative, or let's say it fails in the case with 0 element array. And again, the caller needs to be sure that the value of this maximum sub array should be should fit into this integer, 32-bit integer. He should know that what could be the ranges of this nums array, right? So if he knows the values of this nums array, every element of this nums, and the maximum possible size of this nums, if he knows this information, so again, you could typically determine that you need an int as a return type, or a long long, or maybe some other data type, let's say double. Okay, so yeah, what I could do is basically I could the first approach is generate all the subarrays, find the sum, and then pick out whichever is the maximum value. That's the classic approach, right? So as you might have noticed, I won't be editing any of this stuff that you're seeing, so you'd be hearing some noise. I'm in hostel, so I cannot do anything about the noise. If you see, I'm not even using my fan just to get lower levels of noise. So and it's hot here anyways. uh, and it's it's yes sir, it's 12:21, and that's basically am, early in the morning. So let's first of all, I'll do is I'll get the size of nums. So this is something that I need to do because I need to traverse the list, right? The vector, the array. And what I could do is basically let's say I could use two iterators, I and j, and which will keep track of the starting and the ending location of the vectors that I'm pointing to. So for that, I'll use two for loops. So for int I0, I is equal to 0, I I less than n, and I plus plus, right? So this is the first iterator, and for the second one, for int j equal to 0, j less than n, and say j plus plus, right? So basically what I am now having is two iterators I and j, which will keep track of the sub array that we are currently looking at. Now, one thing that you should observe is if I is so I and j both are starting from 0 in this case. So if I is here and j is here, the subarray is same. But if the values of I and j are swapped, we are still looking at the same subarray. So why to do the calculation twice, right? So I could only consider one of them. So what I'll do is I'll say rather than j starts from 0, j would start from I itself. So j is I plus 1, I plus 2, I plus 3, and till the end. Then I increment I and I check all the sub arrays. Hope you're getting the idea of the code. Now what I could do is either I could do the summation inside this for loop, which won't be anywhere near to the suboptimal way as well, but we could try. So I'll say int current sum is basically 0. So current sum is 0, and what I do for int k is equal to 0, or not 0, k is equal to I, k less than equal to j, and I'll do k plus plus. So basically I'm starting a pointer at I till j, and I'll be summing all the elements. So that would be basically current sum plus equal to the value of nums of k. So always observe, as I and j are always within the bounds of the array, k is always within the bounds of the array or the vector. You can call whatever you want. Yep. So now one we need, as we said, we need another variable that will keep track of the maximum int max possible sum, and I'll initialize this to not 0 because max sum could be a negative value. I'll initialize it to int min. Why int min? Because the thing is int min, because let's say in the worst case all the values in the nums array is int min, so the minimum value could be no less than int min. So int min is the lowest max sum. What is the upper value? Any number that is greater than the int min and within the range of integers is a possible solution to this. So you cannot go below this int min, right? So that is why I declare maxsum as int min. Now what I do is perform a check. I say if what if current sum is greater than max sum, right? That means we we have found a subarray which has a value that is greater than what I have already seen. So what I do is I say max sum is equal to current sum, and we are good to go. And in the end, what you should be returning is this max sum. Okay, so let's look at the code once more while at the same time seeing that did I make some errors or not. So where is the mouse? Okay, so here, so int n, right, the size is used here and here. I declare a maxsum which has the lowest value of int as int min, and I traverse from I from 0 to n. J goes from I to n, right? So I is always with j or behind j. Okay, so I plus plus j is equal to j plus plus. Okay, so the iterators are working properly. I define the current sum as 0, and for k is equal to I, k is less than equal to j, right? So we need to include both of them. and k plus plus, and we increment the value of current sum with nums of k. If current sum is greater than max sum, we update this max sum, and in the end I return the max sum. Okay, so I think this is fine. This is a well functioning working code, and what I'll do is I'll keep it here, and or let's do the optimization in this. So now before that, I'll just write time and time complexity space complexity. Okay, so let's do this. So what is time complexity? Time would be, so this is a constant time operation, and returning, assuming this is again a constant time operation, because you just need to jump back to the caller of this, right? When you'll see the assembly, or you'll see the assembly code, or you'll see the disassembly of this code, what you'll find is there's just a jump statement back to the uh, caller of this function. Whoever called this function, the control bit will pass over to that, and that would be a jump execution. And this maxsum would be stored into some or the other register, right? Just before this, after this for loop, this value would be assigned to some of the registers, basically the registers that hold the return value, and at that point it would, so this return maximum is a constant time operation, and uh, the first two statements are again constant time operation. Now what I see is I have a outer for loop, I have an inner for loop, so this is already time complexity of n square here itself, and we have another for loop inside. So what I could say, the time complexity is somewhere about big O of n cube. Okay, so what is the space complexity? The space complexity is, again, it's just constant. Why? Because we are not using additional, so we are not using a size n array or variable to keep track of anything, let's say. So we are not using the time complexity or any additional space for this. If you want, you could consider plus big O of n for the input. It's just used for keeping, just checking the values, but this big O of n is not at all the part of your solution. It was, so whenever you, this function would be called, this value, this array would already be declared by the caller function, right? So it would already be defined way before this function would be called. So your function is using constant space, but it's big O of n just because you are taking an n size input, and you are definitely, in a way, since you're using the values of nums of k here, so in a way you're basically accessing that big of n space, but that is not used for solving your problem. Okay, so this would work. Now the next thing, uh, I am thinking of, do I keep this code here, or I or should I just create a copy, right? So I'll say this is the brute force brute force approach, and yep, I'll just take this and I'll just copy this, and since I'll be using the same thing again, and I'll just do this after, so I'll do this. I hope you are able to understand what I'm trying to do, and since we have a page break in between, so let's go on to a new page. So uh, I'll say now sub, why is it? Okay, so brute force sub I'll say sub op optimal up approach. So what is it? So suboptimal approach. Now I'll keep this whole thing together, and if you observe, rather than keeping this or calling the sum function inside this for loop, what I could do is I could just take this current sum and I'll just remove this and I'll initialize it here. What I'll say is I'll just remove this, and okay, so yeah, and this is a fine. So what is happening here is while you're iterating, you're also keeping track of the sum rather than doing the sum all together in a different for loop. What you'll do is you'll do the summation while you're iterating through the list, right? While iterating, you keep track of the sum. Whenever you move j, you'll update the sum, right? So what is different here is this won't be k, but this would be j, and this is something better. Okay, so let me just go through this code once and see if I'm missing somewhere a semicolon or a edge case, something that I feel like, or I have extra braces or less braces. Okay, okay, max sum, current sum, and j. Okay, 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 okay. So I feel that this is pretty much a good approach. So what I'll say is I'll say time complexity won't. Okay, so where is the mouse? Just okay, so we need to re-discuss the time and space complexity. So let's look at the time complexity again. This is constant time operation. This is constant time operation. I explained you the what happens in the hardware level, or maybe the assembly level in a way. So we have this outer for loop for n iterations. We have an inner for loop for somewhere about n iterations. This is a constant time operation, so it will take this value in a register, it will take this value in a register and do the summation in the maybe depending on the architecture, it would do the summation and again put back the value back in the register where the current sum is stored, right? And current sum is greater than max sum, so you update the max sum with this current sum and you return. So since there are just two for loops, the time complexity would be n squared, and yep, that is all there is for this problem. And the space complexity is again the same, big of 1 and plus big of n, maybe if you consider the input array as well. You're not using that for your solution, an intermediate uh, part of your solution, you're just using to access the values in the array. So if anyone asks you why the space complexity is big of n, it's just because you're taking an array as an input, right? So you are using a n size vector as a part of your solution, but it's not a space that you are allocating, it would already be allocated by the caller. And one more thing, in all the cases you see, this is pass by reference, right? So pass by reference is meaning that when you call this function, a copy of this nums won't be created. It is not copy by value, it is copy by reference. So there's a big difference. So copy by reference is just passing the object as it is. It's or if I just remove this, what would happen is the copy constructor of this vector class would be called on this nums array, and a copy of this nums would be created for the function call, and after when you end this function, this the destructor of this vector int would be called to remove the allocated memory. So pass by reference is good because since nums array could be large, and a copy constructor would have a linear time overhead which is not actually required, because you're not updating any values in the nums, you're not modifying the data in itself. So taking by reference is good till the time you're not modifying the data and you're not keeping that in check. Same is the case for this as well. Now the final thing, let's just copy this and control C, and again on a new page, control V. Okay, so I'll say optimal approach. Now, okay, so if I'm saying that this is optimal, what I'm trying to do is I need to find a better way to make this update, right? So any time complexity better than n square is what? It could be linear time big of n, or it could be n log n, right? So in general, when you're seeing the log n complexity or n log n, somewhere you could think about the lines that some sorting or some property of sortedness is being used. Even in binary search trees, the in order traversal is a sorted list, right? So that is why the height is log n, so the searching time is big of log n, assuming the trees are balanced. And that is why we use the red black trees or the AVL trees, which allows rotations, which is a constant time operations, which keep the trees always a binary search tree as a balanced binary search tree. So that allows you to always access and insert elements in log n time. So whenever you see or hear log n, it's more or less related to the values being sorted. Even map is using sorted property. In the case, even the set data structure, that is also using sorting. Binary search tree, as I said, that has elements in some sort of sorted manner. Heaps, priority queues, they are also using login time complexity because of this, what do we say, because of this sorted property. So now if you see this problem, if I sort this nums, right, I would destroy the subarray property, I would lose track of the subarray property. So this is not something I could do. So just for the sake of simplicity, I'll say that n log n won't be the case, right? And since we need to find the subarray, at least we need to look at all the elements, right? For some test case, if all the values of nums are positive, we have to look through all the elements and at least sum all the elements, right? So since we have to look all the elements at least once, the lower limit, or there's no mathematical proof, but the best possible case would be linear time, because at least you would see every element once. So that is linear time, big O of n, time complexity. So since that is the case, what would happen is uh, either you can perform at big of n, or n log n, or n square, or maybe n log square n, somewhere in between. So log square n, you probably won't know of any algorithm which would use n log square n, something like that, because that's not the most common approach or the common problems that you see in the uh, questions in sites like Elite Code and Geeks for Geeks, Code Code Chef. I've not used that. Hacker Earth, Hacker Rank, all sorts of stuff. Okay, so can we improve this? Yes, we could, and this is famously known as dash algorithm. So I'll fill the dash later on, or if for some reason I've already made that algorithm as a part of the title of this video, so you already know what I'm talking about. So for this, I'll prefer to rewrite this whole part again. I don't want to reuse that part. Okay, so in the end, I know I have to return the max sum, and that is what I'm going to do. and assuming the nums array has at least one element. So let's try to do it in linear time complexity. 0 I less than n and I plus plus. So this is the thing, and yep, so I have this as the for loop, and what I'll say is I could use int uh, current sum declared here is it as it is equal to 0. And what I'll do is, first of all, whatever the element that I'm looking at, okay, so this is wrong, so current sum, I'll take the first element whichever it is, nums of I, and current sum is plus equal to nums of I. And okay, so for the time being, don't look at this time and space complexity for the problem. So current sum is plus equal to nums of I, and what I'm doing is I'll say if current sum is greater than max sum, right? That is the case, I perform the update. Max sum is equal to current sum, and this is one thing, right? For every element I try to add new element, and right, what I'll say is this would the next statement that I would write would really bother you, because so for this, if you don't understand it, don't worry, I'll just do a dry run after discussing the code, and you'll get the idea what is happening here. I'll say if, so I hate this auto capitalization. It's good when you're writing some document, but when you're writing code, it would cause compilation issues. You don't want that. So if what? If current sum is less than 0, right? Okay, so current sum could be negative, right? I'll say current sum is equal to 0. I reinitialize that to 0. And this is, if you see, this is the solution, right? This would work uh, if I have not made any syntax error. Just let me do the proper formatting of this code, because good formatting is good for the eyes. Or just okay, so let me just first go through the code and see did I make some mistake at some point of time. Semicolon, 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 current sum nums I is a valid index, current sum greater than max sum, so I found a better sub-array sum. I update this max sum to current sum. In the end, I return the max sum. If I found a current sum less than 0, I reinitialize that to 0. And the whole idea of this algorithm, aka Kadane's algorithm, whatever you want to call it, is the idea of not propagating the negative sum in the front when you're processing the remaining list. So optimal approach, and aka Kadane's algorithm. Okay, so I've been, it's way past my sleeping time, so I'm very sleepy. Anyways, so I'll edit this video in the morning and I'll post this today itself. So the time complexity is big of n because you're just using a single for loop, and this is basically 3 or 4 or 5 constant time operations, so that's big O of 1. So, and the space complexity again, same idea. Constant space, we are using additional constant space for solving the problem. We are using big O of n of the input array. So depending on how you perceive the space complexity, you consider the input array or not. You could modify the answer in terms of whatever you want. Okay, so the point of this is you don't want to propagate the negative sum that you are you, that you are actually having. So we'll look at let's say a test case, sample test case, and that would be the worst possible test case that I'll take. Or okay, so let's say 1, then 2, then -5, then let's say 10, 4 or 3, and -20 and 100. Okay, so for some reason this okay, no, everything's fine. Now what I do is I say max sum is equal to int min, right? And current current sum is equal to 0, right? Initializing this. And now what you see is I'll just do a very weird thing. So for first I is pointing to this value, right? So if you see the code, right, keep this code in mind. First of all, I update the current sum with this nums of I, then I check if it is greater than a maximum. If it is less than a maximum, I update the current sum. So I'll use this algorithm, and if you observe what is the maximum sum of the subarray, so the value is exactly 100 in itself, right? So what I'll do is I'll update the current sum to 1 because I see 1 at I, and since this current sum is greater than the maximum, or what I'll do is I'll just update this like this. So I'll put an arrow so you'll see the updates, and so this would be 1. Okay, so just yeah, so this is 1 and 1. Now what would happen is I goes to 2, so current sum is 1, and now I update the value to 2, and I again see the it's greater than the maximum, so I update the maximum, right? Okay, 2. Now what I'll do is I'll just update update I to -5, and I'll say the current sum is what? Current sum is 2 plus -5 is -3, and since maximum is greater than mm, this current sum, so this remains 2 as it is. So this is having no update. But since this value is negative, what I do is update this to 0. Why? Because okay, so first, so this was -3. Let's say we did not do the update. We did not do this if statement update. So you see what will happen is I'll now see 10, right? So if I add 10 to this value is 7, and then I'll update this value to 7. But the problem with this is if if you had just considered this 10 as the subarray, right, you'd have a maximum sum as 10, but you are only able to find 7 because the sum you're considering the sum before, so the values that you got before into your answer. But since the sum of this is negative, you are basically, if you forward or propagate that negative value for the remaining list, you're just going to decrease the net value. So whenever I got 3, I update that to 0. If you saw, right, I do the current sum update to 0, and now when I see 10, so this would be 10 and this would be 10 again. Good. Now I see this 3, so what I'll do is I'll update this to 3 and this to, okay, so this would be 13. I add 3 to 10, right, current sum, and since this is greater than the maximum, I say the value is of maximum is 13. So given, so I need to increment the I as well, right? So given this array, this subarray, your maximum subarray sum is 13 in this case. Okay, so now what I do is I push this I to 20, minus 20 basically. Now I'll do the update. So this is what? This is minus 7. If I add 13 plus minus 20, this is minus 7. And this would remain as it is. But since the fact that minus 7 is less than 0, I update this again to 0. Why? Because again, if we propagate a negative value, there's no use. So now I push this I one step ahead. Now what I see is the value is 100. I do the update in this, so this would be 100 and this would be 13. This would be 100 again because I update the maximum to whatever the value was stored in. Maximum is what? Maximum is the current sum. So that is what I'm trying to do. And after that, this I would go beyond the elements in the list, and at this point we break out of the loop because I would be equal to n, and we break in that case, and the final value of our max sum is 100, and that is what we are going to do is to, let's say like this, we return 100 in the end. Okay, so we saw three ways to solve this. Given this problem statement, the brute force is just to do an n cube operation. Then the suboptimal approach would be to do the n square operation. Basically, you do the summation while you're traversing the subarray, right? While you're finding new subarrays, you keep track of the sum. So you are getting rid of a single for loop using this. That would take the time complexity big of n square and space complexity as I discussed earlier. Now the most optimal approach is a linear time solution because at least you have to see every element once, right? And this is a single pass solution which is big of n, so we know that this is the most optimal approach. Most optimal. You cannot go better with the given constraints, and since you don't know any idea of the elements in nums, so given that you have no information basically, this is the best you could do, right? So big of 1, big of n, that's the best you could get for this problem, and this is the most optimal problem. You should not worry about finding a approach that would take a better time complexity than big of n, because you cannot do anything better than this. Maybe you could find an algorithm which has maybe 3 statements less, 3 constant times statements less, but you won't be, in the end it would still be with a time complexity of big of n. So yep, that was the whole video all about, and this is a bit different format that I am not comfortable, or I don't generally do like videos like this. So what I'll say is, if you like this type of format, do tell me in the comment section below, because it will actually help me that should I continue the series or not, because nowadays I'm actually practicing this format of coding in the Word doc without the compiler, without anything, and I hope this is working. At least if there is a syntax error, that's a different thing, but I'll assure you this, the logic is correct, right? At least if you get the logic, you can write the code, right? And anyways, when you have an access to a compiler, the compiler would throw a lot of errors, that this is an issue, that is an issue, you missed a semicolon, you uh, used a variable which you did not declare. So yep, so even if you do this in Python, the logic would be same, but and yeah, if you want this document as part of the video, I could just basically send you the I can just upload this document as a PDF in the description below if you want this. Otherwise, I'll just say that keep this, you could just write this on your own. It's not a big deal. And if you want to write in a different language, you're welcome to do so. And yep, I'll I don't know what I'll be making a video on next, but I'll see you next time. And thanks for watching. If you're sticking, it really means a lot if you have watched the whole video till now. I don't expect anyone to watch the video till the end. I don't feel like it. So if you did watch it till the end, drop that in the comment section below, because no one would be watching this whole video. And yep, thanks for watching, and I'll see you in the next video.